Good morning, Geometry Advanced. Today we are going to work on section 8.5. We are going to use properties of trapezoids and kites. So we are still working with our quadrilaterals. For these warm-ups, first we need to find the values of x and y. Notice that in this diagram they marked these as parallel sides, so we need to use that. Remember, if you have parallel lines and they are cut by a transversal like we have here on the side, then these are consecutive interior angles, so they must be supplementary or add up to 180. So x plus 55 equals 180, which means x would equal 125. Hopefully you can see that you've got another transversal for those same parallel lines on the other side. And for that one, we still have y and 55 degrees, which means our equation would look similar and y would also equal 125. All right, warm up number 2. I need to use this same diagram, but I'm going to need to make a little space above it. So this one says that if we have rays AX and BY, so ray AX would be on this left side of my diagram. That's pretty close to it. And then BY is on the right side of my diagram. Can't seem to extend it. There we go. Okay. They intersect at point P. So point P right here. What kind of triangle is triangle XPY? All right. Well, if we look at the larger triangle, so the triangle APB, hopefully you could see that this larger triangle is going to be isosceles because those base angles are congruent. So these sides would be congruent. But because we have parallel lines, we know that these little angles here are also going to both be 55 degrees. These 55-degree angles are corresponding on those parallel lines. So if we're just looking at triangle XPY, this triangle here, it would also be isosceles because we still have those sides congruent across from the base angles. So it would be an isosceles triangle. As we're going through these videos, remember if you have any questions, please write them down so that you can comment them or email them to me. And that way I could potentially make a little video answering all of our questions if I need to. All right, let's get into today's notes. Remember to pause these if you need more time to write than I give you while I'm talking about it. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are the bases. Note that a trapezoid has two pairs of base angles. The non-parallel sides are the legs. So let's label this diagram. Remember, if two sides are parallel, we mark those with the little triangles or little arrows. So I'll make these my parallel sides, one pair. Those are the bases. So this is a base up here, base. Oh, excuse me. Okay, we've got our bases, which means it has two pairs of base angles. So the base angles are on the same base. So I'll put a star in these two. Those two base angles are related to each other. And then this up here, I'll make little circles. This is another pair of base angles. We'll talk about relationships between base angles in a little bit, but it's important to know that these two are on the same base. So this is a base angle pair, and down here we have another base angle pair. The non-parallel sides are the legs. So over here we have one leg. Over here we have another leg. And that is our basic trapezoid. So only one pair of parallel sides. Because it doesn't have both pairs of sides parallel, it is not a parallelogram. So we cannot assume any of those relationships about parallelograms. Opposite sides are not necessarily congruent. Opposite angles are not congruent. All those things. Cannot assume them for a trapezoid. Show that XYZW is a trapezoid. If we're trying to show that it is a trapezoid, we need one pair of parallel sides. Hopefully you can see that we want to show that YZ is parallel to XW. That's what we want. In order to show that, what do you think we need to use? If you were saying or thinking slope, you would be correct. We need to know that the slopes of those lines are the same in order to know that they are parallel. So let's first start with our slope of YZ. Remember, slope is y minus y over x minus x. It might be helpful to know the coordinates of those points. So the coordinates of y would be -1, 4. The coordinates of z are going to be 5, 1. Okay, so y minus y, I could have 4 minus 1 over x minus x, -1 minus 5. That would give me 3 over -6, which reduces to -1/2. So we also need to find the slope of XW. Again, if we have the coordinates, that might help us. The coordinates at X would be -2, 1. The coordinates at W would be 6, -3. All right, so y minus y, that'll make this 1 plus 3 over -2 minus 6, which would be 4 over -8, which also reduces to -1/2. So since we showed that we've got one pair of parallel sides, we know that this is a trapezoid. Again, pause it if you need to, rewind, ask questions. We'll keep on moving. Another one you might want to pause on. If the legs of a trapezoid are congruent, so remember the legs are the ones that are not parallel, but if they are congruent, the trapezoid is isosceles. If a trapezoid is isosceles, then each pair of base angles is congruent. If a trapezoid has a pair of congruent base angles, then you know it is an isosceles trapezoid. A trapezoid is isosceles if and only if the diagonals are congruent. So all of these are just about isosceles trapezoids, not any old trapezoid, only isosceles ones. Okay, pause if you need to take more time to write these down. Here on example 2, we are shown an isosceles trapezoid. We are asked to find the measures of angle F, angle G, and angle H. We know that this is an isosceles trapezoid because we have bases that are parallel, and we have legs that are congruent. Remember, the ones that are parallel, no matter where they are, on the sides, the top and bottom, if it's slanted, the ones that are parallel are the bases, the other two are the legs. So because the legs are congruent, this is isosceles. So you know that your base angles are congruent. That means angle F has to be congruent to angle G, and angle J has to be congruent to angle H. In this case, the measure of angle H is probably the easiest one to know. It has to equal 110 degrees. To find F and G, we know they are going to be the same, but this goes back to one of our warm-ups. If we have these parallel lines cut by this transversal, then these are consecutive interior angles, and they have to add up to 180 degrees. So that means the measure of angle G has to be 70 degrees. And the measure of angle F is the same as angle G, so it is also 70 degrees. Easy enough. Again, only true for the base angles to be congruent when it's isosceles. All right, let's keep it going. The midsegment of a trapezoid is the segment that connects the midpoints of the legs. Again, the legs are the ones that are not parallel. The midsegment of a trapezoid is parallel to each base, so we could add in another little parallel triangle on MN. And it's half the sum of the lengths of the bases. So the midsegment is equal to half of base 1 plus base 2. Or for this particular diagram, we could say MN is equal to 1/2 of AB plus DC. Okay, so two things about it. It's parallel to each base. Its length is half the sum of the bases. In the diagram, HK is the midsegment. Find X. All right, so one way we know that this is the midsegment on letter A is the fact that they marked the pieces of each leg as being congruent. So we know that H and K are midpoints anyway. So in order to do this, we're going to find X. X is the midsegment. So X is equal to 1/2 of the sum of the bases. The bases, in this case, are 6 and 18. A couple ways you could do this. You could distribute the half, or you could work inside your parentheses first. It doesn't matter to me as long as you get X is equal to 7 centimeters. Okay, same thing on this next example. HK is going to be our midsegment. I'll go ahead and mark those just to be sure that we know HK is the midsegment. So this time our mid-segment is 2x minus 1. That's going to be equal to 1/2 of the sum of the bases. So 10 plus 44. All right, just a little bit of algebra work to solve this. Add 1 to both sides, you'd have 2x is equal to 28, and when we divide, we would get x is equal to 14. Okay, finding the length of a midsegment should be pretty straightforward. Oh, except I got x, but what didn't I find? I didn't find the length of the midsegment. Silly me. So really, oh, that's fine. They wanted x. I'm getting ahead of myself. They wanted x, so we can stop there. If we wanted the length of the midsegment, technically we should have stopped here. The midsegment would have a length of 27. We used that to find x. Okay, we'll keep it moving. A little more writing on this next slide. A kite is a quadrilateral that has 2 pairs of consecutive congruent sides, but opposite sides are not congruent. So you got a diagram of a kite over here. If a quadrilateral is a kite, then its diagonals are perpendicular. Perpendicular meaning it makes a right angle or 90-degree angle. Okay, so if we look at the diagonals in this diagram, it should be pretty clear that those would intersect at right angles there. Next theorem, if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. Note that the angles always lie between the 2 non-congruent sides. Non-congruent sides. So if I take the diagonals back out of that diagram, we should be able to see that this angle and this angle here are going to be the pair that's congruent. So they're the angles that are between the non-congruent sides. All right, if you need more time with this, go ahead and pause. I'm going to keep going. Find the measure of angle C in the kite shown. All right, the measure of angle C. Well, they gave us 2 angles, the non-congruent ones. We need to know that the measure of angle C is going to be the same as the measure of angle A. Okay, those are going to be the congruent ones. So if I don't know angle C, I could label it with an X, which means I would also have to label angle A with an X. This is going to go back to something we talked about earlier in the chapter. The angles inside any quadrilateral have to add up to 360 degrees. So we're going to take x plus 84 plus 140 and set it equal to 360. Yes, you could think through it a different way. You could add these up and subtract from 360 and then know it has to get split evenly between the 2 remaining angles. That's the same thought process that we have written out here. It's just representing it a little bit differently. If we combine like terms, 2x plus 224 equals 360. Subtract 224 from both sides. That leaves us with 2x equals 136. Divide by 2, and x would equal 68. Okay, and we had labeled angle C with 68, so that would be our degree measure for both angle C and angle A. All right. Find the value of x. This time we don't know the last angle and we don't need to find it. You need to be able to recognize which two angles in a kite are going to be congruent. In this case, that's going to be the one on the left and the right. They're between the non-congruent sides. So we simply need to set up an equation that says 2x is equal to 111. We can divide both sides by 2. And x would equal 55.5. Pretty straightforward. Find the side lengths of the kite. Okay, so we have a kite, which means that we know that these two sides better be congruent and these two sides need to be congruent. We know that we've got diagonals that should meet at a right angle. So the first one I'm going to find is going to be AB. So if I'm looking for AB, I'm going to focus on this right triangle. I'm looking for the hypotenuse, which we usually call C. What am I going to use? Hopefully you're thinking, writing the Pythagorean theorem. So we know that if we label this C, 8 squared plus 7 squared would equal C squared. (64 plus 49 equals C squared). 113 equals C squared. So C is equal to the square root of 113. Okay, you could get a decimal approximation for that. I don't think it's necessary in this case. So I'm going to erase a little bit here. We can add some of that back in. So I know that this side is the square root of 113, which means AD is the same thing, square root of 113. Next, let's shift our focus to find BC. So again, I'm looking for a hypotenuse. I'll label it C on this side this time. So this time we have 7 squared plus 10 squared equals C squared. 49 plus 100 equals C squared. 149 equals C squared. So this time C is the square root of 149. Again, you could get a decimal approximation, but that's not really necessary. BC is the square root of 149, which means DC has to be the same thing. Okay, write down any of your questions, concerns, and email those to me. Your homework is out of the textbook. I will have directions on today's assignment about how you will submit that to me. If you do not have your textbook at home, look in our Google Classroom feed, and I posted a PDF of all the Chapter 8 assignments. So you'll just have to scroll to find it. So a PDF of book assignments is in our Google feed. You might have to scroll to find the PDF announcement. You might have to scroll in the PDF to find the 8.5 assignment, but it'll be in there. Look for the directions on our assignment for today about how I want you to submit your work.